for Research and Security Prices at Chicago. Okay.
Welcome to Take a Deep Breath. Today's breathing exercise is box breathing using your nose.
CRISP, as it's called.
This box breathing exercise has been designed with a longer exhale, which will help improve the stimulation of your vagus nerve, which will help get you into a parasympathetic nervous state, or what some people call rest and digest. In short, this exercise will help you relax, unwind and feel less stress. Very simple practice, and we will guide you through it with breathing sounds. So sit back, relax and prepare for box breathing.
So they said, let's get it right. Let's put it on, hey, this is really super modern, a UNIVAC tape. Okay, that's a computer tape, all right? We'll put it on a tape and we'll sell it at cost to anybody in the world. That was, and so the Ford Foundation, the nonprofit, said, good idea, let's do it. So that CRISP tape has launched a revolution in finance because nobody had the data. They were throwing it away. It was not used. So how do you know what Sharpe ratios are if you don't have the data? I mean, you could find it in newspapers, but it wasn't organized right. It wasn't set out right. So with the invention of the CRISP tape in 1960, it really gave impetus to the efficient markets revolution. And by the end of that decade, there were thousands of articles testing market efficiency using the CRISP tape. And in particular, in 1969, Eugene Fama wrote one of the most cited articles in the history of finance, was called Efficient Capital Markets, a Review. So he reviewed all of these studies of the CRISP tape. And it looked authoritative for the first time because we were using the whole universe of stocks all the way back to 1926. That sounded like a long time and a lot of data. And Fama concluded that evidence is, he said it's not uniform. There are some negative results, but the evidence is that markets are remarkably efficient. And this is a truth that we've discovered. And that, it was really a bombshell because he was discrediting, or seeming to discredit, practically all the investment managers in the country. It was a huge industry. And he's claiming the successful ones must have just been lucky because the market is so efficient that we can't see any way that you could make money in the market. And so the high point of the efficient markets hypothesis was probably in the 1970s. I'll call that the high point. It seemed at that time that all of the scholars were finding that there was no way to beat the market. But it started to deteriorate the support for efficient markets hypothesis. And so I want to there's been a change in thinking. Efficient markets is still regarded with respect, but not the same respect that it had in 1969 or in 1970. I have here some indication of how thinking has changed about efficient markets. I had the textbook that I used to use for this course. I've been teaching this course for 25 years. Fabozzi et al. Wasn't even written when I started. So I was using the textbook called Brealey and Myers, Principles of Corporate Finance. And I still have all these old editions. It's a very successful textbook. But since I was teaching out of it over all those years, I went back and looked. I don't have the first edition of that book. I have the second edition, 1984. And I was teaching out of it in the same class in 1984. At the end of that book, there's a chapter on the 7 most important ideas in finance. And one of the ideas is efficient markets. And quoting the textbook, Brealey and Myers say, security prices accurately reflect available information and respond rapidly to new information as soon as it becomes available. They do qualify it in 1984. Don't misunderstand the efficient markets idea. It doesn't say there are no taxes or costs. It doesn't say there aren't some clever people and some stupid ones. It merely implies that competition in actual capital markets is very tough. There are no money machines, and security prices reflect the true underlying value of assets. Let me repeat that. Security prices reflect the true underlying value of assets. Okay? That's a pretty strong statement, right? But that's official enough. They just said it in their second edition of the book. Not many people would say that, right? Trust the stock market. Don't trust people you know and love and trust. Trust the stock market. Well, they deleted that from later editions of their book. And I think that's a sign of changes. So I was looking at the 2008 edition. They've now taken on a third author. They're getting tired of coming out with more and more editions of their book. So they've taken on Franklin Allen from the Wharton School. They deleted what I just read. Now it says, I'm quoting from them, much more research is needed before we have a full understanding of why asset prices sometimes get so out of line with what appears to be their discounted future payoff. That's a complete turnaround in the textbook. So this is one of the most popular textbooks, and they've changed completely. So I think we have an idea that started in around the 1960s. It was somehow associated with computers and electronic databases and modern thinking and mathematical finance, and they kind of went too far with it. And they concluded that you just can't beat the market. Another thing I put on the reading list is a reading from the New Yorker magazine. It just came out in December. I thought it was relevant. It's by Jonah Lehrer, and the title of the article is The Truth Wears Off. Subtitle, Is There Something Wrong with the Scientific Method? Well, I don't know if there's anything wrong with the scientific method, but I was interested in this article because what the New Yorker article points out is that a lot of scientists, and this is outside of science, I'm making a parallel here, a lot of scientists who follow careful scientific procedures seem to generate results that are later discredited. And nobody can figure out why. It's like the universe is changing. He gives an example in the New Yorker article. There's and this is from drugs. There's a drug, a class of drugs called second-generation antipsychotics. These are used for people who are either schizophrenic or I guess it can be used more generally than that. But some of the drugs are called Abilify, Seroquel, Zyprexa. When these drugs were first introduced, careful studies that passed muster in the best medical journals found that they were highly effective, and they were written up as a godsend, a way of dealing with problems that used to weigh on people, and wonderful, okay? The medical procedures involve careful controls on studies, including a double-blind procedure. With a double-blind procedure, when you want to test a drug on human subjects, you have to have both the subject doesn't know whether he or she is getting the drug, and the experimenter who runs the experiment doesn't know which one is the drug, right? So you give bottle A and bottle B to the experimenter, and the experimenter is never told which one is Zyprexa and which one is a placebo. And then the experimenter has to write up a whole report on drug A and drug B, not even knowing, okay? This is to eliminate any possible bias. So these drugs passed that. You see what I'm saying? The controls were right. Everything was good. But then, as years go by, the tests start coming out. The new attempts to back up or replicate those start coming out more negative. They didn't disprove the drugs. They just weren't such wonder drugs as they thought. So how can that be? And what the article says, well, it must be that somehow scientific bias, and there's an enthusiasm for some new theory, it creeps in even if you try to make the strongest control. You say, how could that happen with a double-blind procedure? Well, maybe they broke the double-blind somehow. They tried, but the experimenter figured out, and then he started not deliberately fabricating results, but It's the kind of thing where one subject says, I didn't take my Apoplexy regularly. I took 2 tablets last week. I have to decide whether to throw this person out of the sample.
Today's breathing
And then
exercise
I kind of
is
remember
box
that it wasn't-
breathing
the drug
using
wasn't
your
working for
nose.
this person, and it
This
colors my
box
judgment,
breathing
so I throw
exercise has
them
been
out.
designed with a longer exhale,
And
which
another
will
thing that
help
happens is that the
improve
studies that
the
didn't find it
stimulation
might
of your
have been
vagus nerve,
right? Someone
which
might
will
have done
help
an
get you
Apoplexy
into a
test, had gotten bad
parasympathetic
results,
nervous state,
and then
or
showed it
what
to
some
their
people
superior
call
and say, "Should I
rest and
publish this?" And the
digest.
superior said,
In
"Wait
short,
a minute, there
this
must be
exercise
something
will
wrong
help you
here.
relax,
Apoplexy is wonderful.
unwind,
So
and
let's
feel
look."
less
And then they find
stress.
something that might be wrong.
Very,
You
very
shouldn't
simple
publish this
practice,
because
and we will guide you through it with breathing
they find
sounds.
something.
So
there's
sit
the
back,
publication
relax,
process is biased.
and prepare for box
For a
breathing.
while, but eventually it catches up. So I think the same thing happened with the efficient markets hypothesis. In the initial enthusiasm, anybody who found that the efficient markets hypothesis wasn't supported by the evidence, that person would be told, look again, maybe you've done something wrong. And so that's what happened. Now I wanted to do a little bit more history and describe the concept of random walk, which is central to the efficient markets hypothesis. Let me start, though, with a little bit more history, technical analysis. This term goes back, must be over 100 years. Technical analysis is the analysis of stock prices, or maybe other speculative asset prices, by looking at charts of the prices and looking for patterns that suggest movements in prices. The classic text of the technical analysis is Edwards and McGee. McGee has a famous story about he was not a professor, he was a Wall Street analyst. And the story about him is that he believed that you look at the prices and you can predict prices. And in fact, he said, I don't want to look at anything else. I just want to see prices. I'll do plots, and I can, using my judgment, I can figure out what it's going to do. And so the story about McGee is, everyone on Wall Street wants the corner office overlooking the World Trade Center or whatever. He said, I want an interior office with no windows. I don't want any distractions. I don't want the real world impinging on my judgment. So that's McGee. But he said that there are certain things that you see obviously. For example, resistance levels. When the Dow Jones Industrial Average approached 1,000, I think it was in the 60s, 1960s. Right, it's way above that now, as you know. But when it first approached 1,000, technical analysts said, maybe it's going to have trouble crossing 1,000, because that's a psychological barrier. That sounds magical. How can the Dow be worth over 1,000? Wow, I'm going to sell. And so the idea was that people would sell when it approached 1,000. And it seemed, the technical analysts seemed to be right, because the Dow bounced around just below 1,000 for a long time. I think it was a month or a year. Like it couldn't cross the resistance level. So that's one example. I have another example which is from Edwards and McGee's book. How do I get this? It's not coming up. So that's just going to hibernate. My password. There we are. That's Edwards and McGee. This is one of the patterns. McGee was actually a student of psychology, and he thought, certain kinds of patterns seem to have really spooked people. And this is one pattern which he called head and shoulders. Okay? That's the head. That's one shoulder. That's the other shoulder. And he said, when you see this pattern, watch out. It's going to actually totally collapse, as it is shown doing. So he had you plotting. These are stock prices plotted against time. This is, I don't know what these are days. Each of these points is a day. And this is from their book, so it's a hypothetical. You hardly ever see such perfect head and shoulders patterns. And so that's one of the patterns. Maybe that's his head and shoulders. So the question is, does it work? Does it really work? In the early 1970s, when the efficient markets hypothesis was really strong, Burton Malkiel, who was a professor at Princeton, and then later he was the dean of the Yale School of Management, wrote a book called A Random Walk Down Wall Street, which claimed that technical analysis was bunk. And he said many studies have shown that it doesn't work. This head and shoulders doesn't work. None of Edwards and McGee's stuff works. There were lots of studies, but I actually met him at a cocktail party after his book came out. And I said, you didn't footnote all those studies about technical analysis. And where are they? I can't find them. I did a search. Not on the internet. I did it on something else, but I was able to search. And I couldn't find them. Where are they? And I found that he didn't have an immediate answer. I suspected he was extrapolating. There was a literature on testing the market efficiency. They looked for things like momentum, whether that continued. But there was something a little bit wrong with the literature. And not many people really confronted technical analysis. Later, there were people who did look at some of Edwards and McGee's points, and they found some element of truth to them. So I think the answer is McGee wasn't a total idiot, as you might infer from this efficient market theory, that it's not going to make you rich either. You know, it's if anything, technical analysis is a subtle art that can augment trading strategies. I bet David Swenson doesn't do it at all. You could have asked. I don't know if he can. So let me talk about random walk, which is a central idea in finance. And the idea is that if stock prices are, if stock prices are really efficient, then any change from day to day has to be due only to news. Okay, and news is essentially unforecastable. Therefore, stock prices have to do a random walk through time. Now the term, that means that any future movement in them is always unpredictable. So it's like the changes are totally random. Okay, so the term random walk is important. It was coined not by a finance theorist, but by a statistician, Karl Pearson, writing in the scientific journal Nature in 1905. Now, he didn't link it to finance, but what he said is the movement in some, but he was thinking theoretically. Actually, I believe he used the example of a drunk. Okay, let's take someone who is so drunk that each step is random. This person has no direction at all, staggering randomly. Okay? So he starts out at a lamp pole, and what would you predict? This is what Pearson asked. What would you predict his position in 10 minutes? Okay? He happens to be at a lamp pole right now. And what Pearson said is, well, your best forecast is that he's right where he is now. Because you have no bias. He could go in any direction equally likely. So what's most likely? It's that he stays right where he is. And what is the probability distribution? Well, it turns out that the standard deviation around that point goes up with the square root of n steps. Okay, because each step is independent of the other, so the square root rule applies. So if you're asked to forecast his position after an hour, that's a lot of steps, you would say, well, I predict he's right where he is now, but I now have a big standard deviation around it. Pearson's article had a lot of, it's a very simple idea. Among the readers, apparently, was Albert Einstein, who
welcome to Take
Norbert
a Deep
Wiener, the
Breath.
mathematician,
Today's
who
breathing
invented
exercise is
continuous
box
version of the
breathing
random
using
walk
your
called the Wiener
nose.
process.
This box
But it
breathing
got into
exercise has
finance
been
later.
designed with a longer exhale,
In
which
the
will
efficient
help
markets revolution,
improve
they
the
started to
stimulation
realize
of your vagus
that
nerve,
stock
which will
prices
help
look
get you into
more
a parasympathetic nervous state, or
more
what some
like
people
a,
call rest and digest. In short,
random
this
walk
exercise
and
will
head
help
and
you
shoulder.
relax,
You
unwind,
look at
and
these head
feel
and
less
shoulders patterns, you
stress.
look for them, and they're hard to
Very,
find.
very simple practice, and we will guide you through it with breathing sounds.
What is
So
a
sit
random
back,
walk?
relax,
Let me just define
and
it. A
prepare
random
for
walk
box
is
breathing.
where you have a series x sub t equals x sub t minus 1 plus epsilon sub t, where epsilon t is noise, just unforecastable noise, mean zero and some standard deviation. Okay. Ideally, it would be normally distributed, so it would have a bell-shaped curve, and then the math would be very easy and very simple. So I want to contrast that with an alternative, which is called a first-order autoregressive. Let me get my notation here. Let's take a process that starts at 100. That's like the lamppost. And we'll say x sub t equals, how much will you minute? 100 plus some number rho, that's a rho, times x sub t minus 1 minus plus epsilon. Okay, so this is an AR1, first order autoregressive. It's like it's like a regression model where 100 is the constant. Well, 100 minus 1 minus rho is the constant time, and the coefficient of the lagged x is rho. Okay, and we usually require that rho is between 0 and 1, between minus 1 and 1. Normally, rho is positive, so that means that it's mean reverting, but slowly. You see what this is saying? First of all, in the special case where rho equals 1, well, that would be, I wouldn't call it a AR1 anymore, because it reduces to a random walk. Well, if you make rho 1, then the constant term drops out. I've got 100, there's no constant term. And then I've got x sub t equals x sub t minus 1 plus epsilon, so that's random walk. Right? So in the extreme case where rho gets to 1, and a first order autoregressive process converges to a random walk. I wanted to show you some simulations of it. If I can. So, okay, except I can't. Okay, this here is a plot I had. Let's first look at the black line. The black line is the Standard & Poor's Composite Stock Price Index in real terms. I have that from 1871 until recently. Okay. That's just there for comparison. That is the actual stock market. Okay. The pink line is a random walk that I generated using this formula and a random number generator that you can that generates random normal variables. Okay. I started them out at the same level, but don't they look kind of similar? I mean, the thing is that if you look at the stock market without comparing it with a random walk, it looks like it has patterns in it. In fact, here's a head and shoulders right here. Right? Bang, bang, bang. When is that? I think this is, when is that? I'm not sure. 1930, 31. And this is just before the war. I'm not sure exactly when those. There's a nice head and shoulders. Hey, Edward, sort of right? But I can find head and shoulders up here too. Maybe. And the pink line. The pink line, you understand it? The black line is actual U.S. history. That's the stuff. The pink line is a fake document generated with pure random noise. And the fact that it's going up is just chance. Now I can actually use this program to generate other things. So I'm going to, the black line, this should change. Let me see, make sure it's working here. Yeah, the black line is the same. I'm not going to change the black line. The black line is history. I just did a brand new random walk calculation using my random number generator, which is there on Excel. That looks pretty good, doesn't it? I just did that. I'm going to do more for you. Which one is the real stock market? I find that hard to tell, right? This was an insight. The insight is that people get deceived when they look at stock price charts. They think they see patterns. That pink line is guaranteed to have no patterns because I generated it so that there are no patterns, except random patterns. But when I look at this pink line, which just came up, look at that uptrend. Wow. That's called a bull market. It goes up. And I could make all kinds of theories about why that's happening. But those would be fake theories because I know what's really happening. This is pure randomness. So I'll do it again. I can do this forever. That's another one. Here the trend wasn't quite so positive. Well, actually, I have to say one thing. I forgot. I did put an uptrend in the random walk. Sorry. In this simulation, I did add a constant. So that otherwise it was I forgot what I did. It was a random walk with trend. But it doesn't guarantee that it will go up. I'll do another simulation. I'll do another. See how fast I can do these? This is the wonder of modern computing. That one doesn't work. If this were our history, people would say, the amazing stock market of the first half. Look at that stock market of the first half of the 20th century. And we would be devising all kinds of theories to explain it. But in fact, it's just nonsense. It's just randomness. I'll do a few more. Look at that. Boy, that would be a hump shake for the whole 20th century. We would have historians trying to figure that one out. Oh, this one downtrend. This is a bad outcome. This is Jeremy Siegel would not be pleased with this outcome because it has the stock market gaining nothing in 100 years. So these are all equally likely outcomes. Look at that one. If that were the world that we inherited, we would really think there was a linear trend in the market, right? People would be making models saying, it just goes up. Look at that. How straight that market. The point is that you start to see a sort of reality, which is really just randomness. That's why Nassim Taleb, a friend of mine, wrote a book called Fooled by Randomness. I thought it was a great title for a great book. That people don't understand how things are just purely random. And your mind tries to make sense out of them. And you start looking at patterns that have nothing to do with anything. So I can just keep doing this. So maybe I'll stop. Look at that one. Because I'm helped along by the trend that I added in. So I want to see if I can get a downtrend one. Because I put a trend in, it's hard to get a real downtrend. That's sort of a downtrend. That's where there are a lot of negative shocks. Anyway, what I want to do is, so you see the comparison of the random walk with the actual stock market. So the actual stock market looks a lot like the random walk. One thing's different though. Look at this pattern here, 1929, and this is the crash after 29. You know why? I'm not getting that in any of my simulations. And you know why?